So welcome to the second video for the Math 3 review. Given that function, determine the horizontal asymptote and put your answer in exact decimal format. And then we need to figure out where the point of discontinuity that is a whole and leave our answer in fraction form. Okay, so the whole is makes both the numerator and the denominator 0. So to know that, we're going to have to factor. So the top is a difference of squares. So this factors as x plus 6, x minus 6. The denominator, we need something that multiplies to negative 6 and adds to negative 5. And so that would be x minus 6 and x plus 1. Once we've seen those two, this right here, right, this is the value that would create a whole. So the value that creates a whole is when you set that equal to 0, which is 6. So our point of discontinuity that is a whole is the point x equals 6. Or you could write it, oh no, well 6 is, or you just write 6. It depends on what they ask for. Probably they're not going to put x equals, so I'm going to take that off and just write 6. Okay, the next one, the horizontal asymptote. So there's vertical asymptote would be this guy right here. X equals -1 is, whoops, -1. That is the vertical asymptote. And so this would be a vertical asymptote. But to find the horizontal asymptote, you need to look at the leading coefficients and the degree. So if the degree of the numerator is larger than the degree of the denominator, there is no horizontal asymptote. If the degree of the numerator is smaller than the degree of the denominator, the line, you have to use long division. So you divide their coefficients. And if they're equal, then the line y equals 0, or the x-axis, is the horizontal asymptote. So I'll say that again. Okay, there's three rules. So numerator degree is greater than the denominator degree. None. There's no horizontal. The numerator degree is less than the denominator degree. Divide a over b, and it's the line y equals a over b, where a is the top and b is the bottom coefficient. And then finally, if they're equal, the numerator degree is equal to the denominator degree, then it's always the line y equals 0. And those are your 3 rules. Oops, I ran off the camera there, of course. And so in this case, you see the degrees are equal. We have x squared over x squared. So if we have x squared over x squared, they're equal degree, so that was our answer. Now, if I had had x over x squared, that would have been this case. The degree of the numerator is smaller than the degree of the denominator. So it would have been these values, like 1 over 1, the value out front, okay? All right, next one. The function above has a parent of y equals 3 over x. Which of the following functions represents the graph based on the asymptotes? Okay, so the parent of 3 over x, if you want to use a graphing tool, you can, but you still have to explain to me how you know which of these is the correct answer. So it's not that I mind if you use a graphing tool, but you can't just plug these in and say, oh, well, that's the one. You have to show me how you knew. So I'm going to plug in 3 over x. 3 divided by x. Where's x? Right there. And then I'm going to zoom 6 this guy and see what my graph looks like. So that's the parent right there. You notice that there's a horizontal asymptote here, vertical asymptote here at 0. And a horizontal at 0. So x equals 0 and y equals 0. So if A were negative, like if there was a negative out front, like right here, then what's going to happen is that this graph will flip-flop. This will come up here, and this will move down here, right? So your graph will flip-flop. That didn't happen, so A was positive. Okay, now, so I'm going to get rid of that one. It can't be that one because it has a negative out front. The next thing that I know is that my graph was centered here on the axes. And what has happened is it's shifted to the left. The asymptote shifted left 2, and it shifted down 1. So that means H was -2 and K was -1. And so my parent here will be y equals A, but A is not scaling at all. So A is just 1. In fact, A is 1, right? And then my parent is going to shift the x value to the left 2. So that means it's going to be 3 over x minus h and then plus k. So y equals 3 over x minus -2, which is x plus 2, and then plus k, which is actually -1. So it must be this guy, D. All right, which value of x makes the equation true? So one way to do this is to cross multiply. I'm going to go ahead and do that method. I'm going to cross multiply. So 1 times 9 minus 3x is 9 minus 3x. Oops, 9 minus 3x equals, don't forget when you're cross multiplying, you're getting rid of the fraction, x times x minus 3. So 9 minus 3x equals x squared minus 3x. So the 3x's cancel. I get x squared equals 9. I can square root both sides to solve. X equals plus or minus 3. Don't forget your plus or minus. That's where a lot of students make an error. Now, if you substitute these in positive 3, so let me substitute in positive 3. 1 over 3 minus 3 is equal to 3 over 9 minus 3 times 3 is 9. Well, this is a true statement. 1 over 0 is equal to 3 over 0, but you cannot have 0 in the denominator. That would be undefined. And so positive 3 is an extraneous solution. So we're going to try negative 3. If I substitute in negative 3, I have 1 over negative 3 minus 3 is equal to negative 3 over 9 minus 3 times negative 3. And so this is 1 over negative 6 is equal to negative 3 over, this would be 9 plus 9. 1 over negative 6 is equal to negative 3 over 18, and that is true. And so the answer is actually only negative 3. And so if you wanted to, you could just substitute these values in and check them. But I always like to show, if it wasn't a multiple choice test, how would you find it? Okay, next. So we don't know how many terms there are, but it doesn't really matter because all of these go from 1 to 8. So if you needed to find the number of terms, you can review back how to do that, but or count up to see how many missing terms there are, but you don't really need to do that because all of them go to the same value. All right, what you do need to do, this is A1, you need to find A0 because A0 will be what shows up right here, right, the constant terms. And you need to know the difference between adding having parentheses and not having parentheses. So before I can find A0, I need to find D. Well, D is the difference from here to here, or here to here, or from here to here, or from here to here. I can see they're adding the same amount every time. They're adding 4, so D is 4. And I can see that it's arithmetic. Like I can tell that it's an arithmetic. It's going up by the same amount each time. Okay, so my common difference is 4. And if you had a line, like if you had y equals mx plus b, d is your m, right? So it's going to be like 4x, or in this case 4k. So I'm going to get rid of this one because this one does not have a 4K. It has a 5K. Okay, all the others have a 4K. So now I need to know what A0 is. Again, this is my A0. This is my A0. This is my A0. So A0 is either 5 or -5. So if I were to move back a term, so subtract another 4 off, I would be at 5. So A0 is +5. I'm going to get rid of this guy then. And now I need to know, like, why do I need parentheses or not need parentheses? So the difference between these, this one means that if I were summing these up, I would take 4K, meaning when K is 1, so 4 times 1 plus 4 times 2 plus all the way to 4 times the last term, which is 8, and then I would add 5 at the end. So my first term would be 4, my second term would be 8, my third term, and so on. This would not match the sequence that they gave me, or the series that they gave me. However, this with the parentheses means that I will add 5 to every single term. So I would do 4 times 1 plus 5 would be my first term, plus 4 times 2 plus 5, plus all the way to 4 times 4 times 8, my last K, plus 5. And so this would give me 4 times 1 plus 5 is 9, plus 8 plus 5 is 13, plus ... This is matching. The last term would be, 4 times 8 is 32, plus 5 is 37. Oh, it must be D. So without the parentheses, it means you only add 5 at the end. With the parentheses, it means you add 5 to each and every term when you substitute K in. All right, moving on. The sum of the first 9 terms in a geometric sequence is 20, 44. The common ratio is 2. What is the fourth term? All right, so all I know is R is 2. And I do know for the sum of a geometric sequence, it's S sub n equals A sub 1 times 1 minus R to the n. Let me fix that, my bad. 1 minus R to the n over 1 minus R. And they did tell me that R is 2. And they told me the sum of the first 9 terms. So n is 9, S sub 9 is 20, 44, and R is 2. So I'm going to substitute in what I know, and I'm going to find A1. Okay, so 20, 44, that's my sum, is equal to, I don't know A1, 1 minus R to the n over 1 minus R. That's cool, that's just -1. Right, so 20, 44 equals A sub 1 times, all right, 1 minus 2 to the 9th. So 2 to the 9th is 512. 1 minus 512 is -511 over -1. So that just becomes positive. And so now I'm going to divide both sides by 511. So 2044 divided by 511 is 4. Again, I just divided both sides.